Okay, guys, let's get started with the problem. So you have two investment vehicles. One is bond A, what I call bond A, and another is bond B. Bond A gives you 7% return, 7% return with default rate of 3%, 3% default rate. And bond B gives you 9% return with a default rate of 5%. Okay. Now, given that you want to maximize your return, which bond should you invest in? That's what the question is. Given that you want to maximize your return, which bond should you invest in? Now, the way you kind of figure it out is by finding the expected value or expected return for each of these bonds. To find the expected return, we create the table, we create event X, then probability of that event X, and X times the probability of X. Similarly, event X, probability of event X, and then X times the probability of event X. Now, let's go ahead and find these numbers. For bond A, two things could happen. One is you get 7% return, that means 7% of $10,000, which is, by the way, 700. So that's one thing that could happen. You get $700 at the end of the year as investment return. Then the other scenario is that it is possible that the bond issuer goes out of business and cannot give you anything. Not only that you do not get 700, but you also lose your $10,000 initial investment. So that's called the default rate. Okay, so this is the default rate. That means bond issuer is underwater. That means they went out of business or declared bankruptcy. In that case, what happens? You lose all of your $10,000, right? You lose $10,000. So negative 10,000. Now, what are the chances that they will go out of business? That is indicated by the default rate, which is 3% or 0.03. So that's the probability that they will go under and you will lose $10,000. So 3% chance. 3% chance that they will be out of business means what percent chance that they will stay in the business? 3% chance that they will be out of business. What percent chance that they will be in the business? Anybody wants to help me out?
97.
97%, exactly. Because 100% minus 3% is 97%. Thank you. Okay. So 97% chance that they will be in the business. And if you do the math, I think this comes out to be 678. And this is negative 300. Now, expected return for bond A, expected value E of X for bond A is going to be 678 minus 300 is going to be 378. And similarly, we do it for bond B. I'm going to, instead of me doing it, I kind of want you to try your hands on it. So I want you to do the exact same calculation, but for bond B. However, I will do it, okay? So go ahead and spend a minute trying to do this one, part B. Exact same thing, you find the expected value for bond B or expected return for bond B. And I see already somebody got it. So I'll give you just a little under a minute to work on it. So please go ahead and do that. Okay, so for the second bond, 9% of $10,000 is gonna be $900, right? So you could either get $900 or you could lose everything. That means lose $10,000. That's gonna be negative 10,000. The chances of getting, chances of losing everything is 5%, or default rate is 5%. So it's 0.05. Then the chances that you will get $900 is 95%, or 0.95. So this is gonna be 855, and this is gonna be 500, but negative. Now, if you add the last column, that's gonna give you the expected value or expected return from this investment, which is $355. So investment return for the first bond, or bond A, is $378. Investment return, expected investment return from the second bond is $355. A wise investor or a rational investor would probably invest in bond A, because on the average, you are expected to get $378 as opposed to getting $355 from bond B. So your investment choice, investment vehicle would be, in this case, bond A, because you want to maximize your profit. And this one gives you the maximum profit on the average. Okay. Any question, anybody, before I move on?
How did you get 855?
900 times 0.95.
Oh, okay, I see. Thank you.
Any other questions, anybody? All right. Next topic we are going to talk about is continuous random variable. So far, we have discussed discrete random variable, and we have considered two probability distributions with discrete random variables, namely binomial distribution and what? Poisson distribution. We have talked about binomial distribution and Poisson distribution. These two are discrete probability distribution, meaning the random variable X associated with these distributions are countable. So that means it takes on values from this set, 0, 1, 2, keeps going. All right. That's the discrete case. Now, there are scenarios where your random variable is continuous, meaning that it takes on value from an interval in the number line. So we have probability distributions that we'll talk about that involves continuous random variable as opposed to discrete random variable. I have mentioned here specifically with an intention to make a distinction between the two so that you understand. You can compare and contrast. All right. So here X values could be certain numbers like 0, 1, 2, 3, 4, etc. But in the continuous case, X would be a value from an interval. Okay. It could be an open interval too. So basically, it's coming from the number line. You know the number line 0, 1, 2, etc. -1, -2, and so on and so forth. X could be a value coming from this. Now, another distinction for discrete random variable, it is countable. Okay. It's coming from a countable set. Whereas for the continuous random variable, it's coming from uncountable set. Okay. countable set versus uncountable set. So discrete is coming from countable and continuous is coming from uncountable. And just to give you an idea, any interval on the number line is uncountable. Okay, any interval, doesn't matter which interval, how small the interval is, it's uncountable. Of course, I'm meaning continuous interval without any interruption or anything. Now, let's go ahead and talk about a couple of examples of continuous random variable. Now, once again, remember, continuous random variable, it can take on or it will take on values on an interval from the real number line. For our discussion, we'll stick to real number lines, but in more general context is defined on another very advanced concept of mathematics, which is called measure theory. And probability is intrinsically tied with measure theory, but that's way beyond the scope of this class. So we are going to just talk about real numbers. So for our case, we are dealing with continuous random variable, and the random variable X would take on values from the number line, or more specifically from an interval on the number line. And it could be the entire number line in and of itself, from negative infinity to positive infinity, which you will see very shortly. The normal distribution actually takes on values. The random variable associated with normal distribution will take on value from negative infinity to positive infinity. Any question before I move on, everybody? Everyone okay? And also keep in mind, before I go deeper into this topic is a little bit harder. So it may not sink in right away, all right? It may take a little bit of time for you to process the information. So please be patient and hang in. And I'm recording it so you can watch it multiple times and pause it and watch it and whatnot, so that you guys are okay with the ideas. But it may take you a couple of weeks for you to really understand the continuous random variable and the probabilities associated with it, okay? Now, let's go ahead and talk about some properties of continuous random variable and probability as it relates with each other. Now, in the discrete case, we have seen distribution. In the continuous case, we also have distribution, probability distribution. So let's say this is some probability distribution and I'm making it up. Something like this. This is called probability density function, or PDF, okay? Probability density function. So let's say I have mean here, mu. So now your random variable X is along the horizontal axis. Now, if you want to find the probability, unlike discrete case, probability is measured differently. In the discrete case, both binomial and Poisson distribution, you had formulas, okay? You had formulas. In the continuous case, we do have formulas, but that involves calculus, okay? Finding the probability. So that's going to be beyond the scope of this class. So we are just going to use some tables. I'll give you predefined tables, and you will use those tables to approximate the probabilities for normal distribution. And for the rest of the class, we'll be talking about normal distribution, and more specifically, standard normal distribution that has mean of 0 and standard deviation of 1. That standard normal distribution is something we are going to be talking about for the rest of the semester. Now, how do you define probability for continuous random variable? First of all, note that for a single point, okay, for a single point, let's say probability of X is equal to A is always 0 for the continuous case. Probability of a single point is always 0. Now, if you want to find the probability associated with a random variable X, you actually look at an interval, let's say A and B. You find the probability that random variable, in particular, continuous random variable X falls between A and B. So that is to say, you write down probability of A is less than X is less than B. And that is defined by the area under the curve between these 2 points. So I have point A here and point B here. Probability that the random variable, continuous random variable X falls between A and B is given by this shaded region. Okay, this shaded region gives you the probability. So probability is defined as the area under the density curve, which is basically a fancy name for probability function. Okay, probability is defined as the area under the density function. Now, since the probability of a single point is 0, remember, this is 0, there are a couple of things we could say. Probability of A less than X less than B is the same as the probability of A less than equal to X is less than B. The difference, both of these are equal. Because the difference between this one and this one is a single point. A is included here, A is not included here. But the probability of a single point is 0, so it really doesn't matter. So the probability of this and probability of this are going to be the same. Or also, probability of A less than X less than equal to B is the same as this, by the way. Again, the difference between these two is that you included B here, whereas you did not include B here. And in particular, you could extend it to probability of A is less than equal to X is less than equal to B. Really, it doesn't matter whether you add 1 point or 2 points with the interval. The probability of individual points are 0, so it's going to give you the same probability. So unlike discrete case where probability of X less than A is not equal to, in general, probability of X less than equal to A. In the discrete case, that is not the case, okay? They are different. But in the continuous case, so this is discrete. In the continuous case, however, probability of X less than A is the same as the probability of X less than equal to A. Keep in mind. Now, why is that the case? So let's consider a point C. What is the probability of C? Just single point. Remember, in the continuous case, probability is defined as the area under the curve, area under the density function or density curve. However, if you have a single point, you really don't have an area. You have a vertical line, you can think of it that way, which has a height, but you don't have any weight. Single point doesn't have any weight. Here we have a weight, B minus A, right? That's the weight, which is this portion, B minus A. But here there is no weight. C minus C is nothing but 0. So if you have height but no weight, then the area becomes 0. So it does make sense in sort of geometric fashion as well. You can actually look at this diagram and make some sense why the probability of a single point should be 0. Okay, probability of a single point, let's say C, is equal to 0. So probability of this point, probability of X is equal to C is going to be 0. Just think of it. This does not have any weight. Therefore, weight is 0. 0 times any fixed number is always 0. All right, so that's pretty much what is in this slide. So main thing from this slide you should know is that probability defined in the continuous case as area under the density function or area under the function or density curve. Different people use different names, so don't get confused by it. Probability is defined as the area under the density function or density curve. Next, probability of a single point is always 0. Probability of a single point is always 0. The easiest continuous probability distribution is the uniform distribution. Okay, the easiest one. It tells you that the probability over an interval is constant. That means it does not change. This is the easiest one, and it's very important for you to understand this example, because this will help you visually kind of see how continuous probability distribution work out. Okay, so please pay attention. So this distribution is called uniform distribution, and it is defined as this. So f of x is equal to 1 over b minus a if x is an element of a comma b. If x lies in the closed interval a and b, it is defined as 1 over b minus a, or is equal to 0 otherwise. For any other value that is not in that interval, in this interval, is going to be 0. The function is defined 0. Now, how does it look like? Let me just show you. So let's say this is your x. So probability will be defined for a window. Let's say this is your a and this is your b, and the probability in this window is going to be constant. That means this line is representing the probability. So it's constant. It has fixed height. And that height, by the way, is defined by 1 divided by b minus a. That's exactly what you see here. 1 divided by b minus a. Okay. Now, if you pick any point x in between b and a, you have a probability defined for that point. However, anything outside of b, a, b, the closed interval, like something here, the probability is 0, or something here, the probability is 0. And this definition of probability distribution or probability density function is called uniform distribution. Uniform, as the name implies, is the same everywhere, uniform distribution. Then there are other distributions which are commonly used. Most common is the normal distribution. Okay, normal distribution. Then previously I used to teach in this class, even though it was not required, exponential distribution. Okay, that's another distribution. But nowadays, the course has been reduced to 4 units from 5 units. So I don't cover it anymore, exponential distribution. Okay, now having said that, let me go ahead and give you a specific example that would help you see things better. So let's look at these. A couple more things about uniform distribution. The mean for the uniform distribution, that is mu, is a plus b divided by 2. And variance, or sigma square, is a minus b whole square divided by 12. And of course, sigma, or the standard deviation, is going to be square root of a minus b whole square, all of it divided by 12. Remember, standard deviation is the square root of the variance, or variance is the square of the standard deviation. Standard deviation is the square root of the variance, and variance is square of the standard deviation. Now, let's move on and do an example. So at your school, they are trying to test the alarms. Let me make it a little bigger so that you can see it. At your school, they're trying to test the fire alarm system, and they're gonna do it, they said for sure, they're gonna do it between 9 a.m. and 11 a.m. So 9 and 11 a.m. The probability of testing the fire alarm during this period is uniformly distributed. That means it's a uniform distribution. This is kind of like tilde, okay? That tells you X is a random variable. So this tells you, so this is X U 0, 120. That tells you X is a random variable that is uniformly distributed over the interval 0 to 120, which is like A and B. Remember, uniform distribution had A and B. So these are your A and B. Based on this information, they want you to find the following. What is the average? That means mu. They are asking you what is mu. What is the average number of minutes that one can expect to wait for the alarm to ring? Okay. What is the variance? That means they're asking for sigma. What is the standard deviation, which is just the square root of the variance, sigma. Find the probability that you'll wait 12 minutes, you'll wait up to 12 minutes for the alarm to go off. So that means they are asking you to find the probability that X will be less than or equal to 12. That means you will have to wait up to 12 minutes. Not exactly, I should probably have added something here, up to 12 minutes. Not exactly, up to 12 minutes for the alarm to go off. Actually, I kind of clarify it here. Find the probability that 0 is less than X is less than 12. And then find the probability that you have to wait more than 30 minutes. That is, find the probability of X is greater than 30. So probability that you have to wait more than 30 minutes, okay? Note, this is the same as saying probability of X is greater than or equal to 30, okay? Because probability of a single point is 0. Find the probability that you have to wait exactly 60 minutes. Find the probability that you have to wait exactly 60 minutes for the alarm to ring. Now, does anybody know what that value is gonna be? Anybody knows? I just told you, probability of a single point is what?
0.
0. So probability that X is gonna be exactly 60 is 0. I just showed it to you. Then find the probability that you'll wait between 20 and 50 minutes. So in this one, you need to find the probability that you will wait between 20 and 50 minutes. So 20 is less than X is less than 50. So these are all the questions. And remember, alarm is being tested between 9 and 11. That is 120 minutes. That's why we have 0 and 120. So let's go ahead and work on this problem. Okay, so this is how the distribution looks like. So I kind of do the following. So there's your 0 and there's your 120. So I'm scaling it in such a way so that 0 is set at 9 o'clock and 120 would be set at 11, 2 hours, like 120 minutes. And having said that, then what is this height or this height? Remember, the formula says f of x, or definition says f of x is equal to 1 over b minus a for x in the interval, a to b. In our case, A is 0 and B is 120. So this is going to be 1 over 120 minus 0, which is just 1 over 120. So this is 1 over 120. The same, 1 over 120. The height does not change, okay? So this is a horizontal line, so that means height does not change, or y value does not change. Now, look, the probability is non-zero if you are between 0 and 120. As soon as you get off this window, it falls to 0. So probability here is 0. Probability here is 0. Okay? Probability to the right of 120 is 0. Probability to the left of 0 is also 0. So there is this strict window where you have uniform probability. That's why we call it uniform probability, because you have probability in a window and it is all fixed. It doesn't change. That means the alarm, fire alarm, could be tested anytime during this window. It could be tested anytime during the window of 9 to 11 or during these 120 minutes. So now let's go ahead and answer each of these questions. A, find mu. But remember, mu is equal to A plus B divided by 2. In our case, 0 plus 120 divided by 2, which is 60. So 60 minutes. So on the average, a person may expect to wait about 60 minutes for the alarm to ring. On the average, a person may wait 60 minutes for the alarm to ring. Number B, what is sigma square? But remember, sigma square is A minus B whole square divided by 12, which is 0 minus 120 whole square divided by 12. So sigma square is equal to 120 times 120, okay? 120 times 120 divided by 12. 12 goes into 120, 10 times 10 times 120 is 1200. So your sigma square is, excuse me, 1200. Part C, what is sigma, which is easy. Square root of sigma square is square root of 1200, which is square root of 400 times square root of 3. Remember, you could use the properties of radicals to distribute. So 1200 is 300, 3 times 400. So that's going to be square root of 400 times square root of 300. So sigma is equal to square root of 400 is just 20. I factored it in such a way so that I could take out a perfect square. 400 is a perfect square, or largest perfect square I could factor out from 1200. So 20 times square root of 3. That is going to be your standard deviation. Okay, any questions so far from anybody? Is everyone okay with it?
It's a lot, but I think if I do some more examples, I'll catch on.
Yeah, I know it's a lot. That's why I'm recording it, so that you can go ahead and watch it multiple times and slowly absorb it.
I don't know if you've ever seen that GIF where all these mathematical equations are floating around the screen and the woman looks really confused looking around. That's kind of how I feel right now, but I'll get it.
Okay. D is this one. Probability that you will wait less than 12 minutes, probability of x less than 12 or less than equal to 12, it doesn't matter. Which is, by the way, the same as probability of 0 is less than equal to x is less than equal to 12, because you cannot wait less than 0 minutes. So that's why our starting point. So if 0 is right here, so let me use a different color so that you can really see it. If 0 is right here, let's say 12 is right here. So how would I find the probability? Remember, I defined probability as the area under the density function. So that would be this rectangular area. It's so easy to use uniform distribution and explain the concept of probability in the context of continuous random variable. Is just straightforward rectangular area. Not all the distributions or hardly any distribution other than this has this kind of very interesting feature where you find the probability so easily. So what is the area of this shaded rectangle? We have to find the height, which is this, that is 120. And we have to find the weight, which is this, 12 minus 0 is 12. So this is very easy. The area is length times weight, or in this case, height times weight. So it's going to be 1 over 120 times 12, which is 1 over 10, because 12 goes into 120 10 times, which is 0.1, which is just 10%. So there is a 10% chance that you will have to wait 12 minutes or less to hear the alarm. Part E, the probability that you'll wait more than 30 minutes. Probability of X greater than or equal to, again, doesn't matter, 30 minutes. So 12 is here, so let's say 30 is here, okay? So this is where 30. So more than 30 minutes. So you don't look at the area to the left, you look at the area to the right. So that means we are talking about this entire area. Okay, this entire area. You're looking at probability X greater than or equal to 30. That means what are the chances that you will be waiting for more than 30 minutes to respond to this alarm. Now, height is still 120, but the weight is different. Width is going to be 120 minus 30, which is, by the way, 90. So this area, shaded region on the right, would be 1 over 120 times 90. 30 goes into 93 times, 30 goes into 124 times, that's 3 over 4. That is also equal to 0.75, which is 75%. So there is a 75% chance that you will have to wait more than 30 minutes for this alarm to go off. So that's this one. And F is the easy one. Probability of a single point X is equal to 60. It has height at X equal to 60. So let's say 60 is right here. Okay, 60. It has a height, but it doesn't have any weight. So the area must be 0. G, find the probability that 20 is less than X is less than 50. Once again, you could put less than or less than equal to, doesn't matter, only for continuous random variable, not for discrete, not for binomial and Poisson distribution, distributions that we talked about, only for continuous random variable. You could say less than or less than equal to, greater than or greater than equal to, is the same. Now, to show this one, let me just draw the diagram again. That will help you see things nicely. So there's your 0 and 120, and 20 is right here, let's say, and 50 is right here. You want the probability that the random variable X would fall between 20 minutes and 50 minutes. That means what is the probability that the alarm will go off between 20 and 50 minutes. So there will be this shaded region. And this height, by the way, is still 1 over 120, right? And what is the weight? Width is 50 minus 20. 50 minus 20, which is 30. So you'd write 1 over 120 times 30. Now, if I simplify it, 30 goes into 124 times, that gives you 1/4. That is, by the way, 0.25, or which is also equal to 25%. So there is a 25% chance that you'll have to wait between 20 and 50 minutes for the alarm to ring or alarm to go off. All right. Okay. Any question, anybody?
Not so far.
Now, I'm going to give you a few minutes to work on a similar problem. Exactly the same thing, okay? Exact duplicate of this problem, but I want you to get some practice on it. And then I want you to ask me questions about it, all right? So this problem, we have a window of 3 hours or 180 minutes, correct? So we could just do it like this. So that's it. This is my 0, and this is my 180. And I have probably defined between these 2 points. And from the definition, you know that this height is gonna be 180 minus 0, 1 over 180 minus 0. So which is just 1 over 180. So probability is constant between 0 and 180. And everywhere else, it is 0. Okay, so it keeps going forever this way, forever this way. So in theory, it goes to positive infinity in this direction and negative infinity. Oops, not 8, negative infinity in this direction. Now, easy problem. Number 1, mu is a plus b divided by 2. A plus b divided by 2 is 0 plus b is 180 divided by 2 is 90, right? 180 divided by 2 is 90. On the average, you can expect 90 minutes for one to wait. Number 2. What is sigma square? Sigma square is equal to a minus b whole square divided by 12, which is gonna be a minus b is 0 minus 180 whole square divided by 12. That is 180 times 180 divided by 12. So what does it come out to? 4 goes into 12 3 times, and 4 goes into this 45 times, and 4 goes into 45, 3 goes into 45 15 times. So 15 times 180, 15 times 180 is 2700. So that is your sigma square. So sigma square is equal to 2700. Now, what is sigma? That is just the square root of it. Square root of sigma square is equal to square root of 2700, which is to say sigma is equal to square root of 2700. Don, this is what you are asking me. So I want to factor out 2700 in such a way so that I can factor out the largest perfect square. So what would that be? As it turns out, it is going to be 900, because 900 times 3 is 2700. So it's going to be 900 times 3. So that is going to be square root of 900 times square root of 3. The square root of 900 is 30. So it's going to be 30 times square root of 3. 30 times square root of 3. Number 4. What is the probability that you have to wait less than, or one has to wait less than 60 minutes? So what's the probability that someone has to wait less than 60 minutes? So again, 60 is somewhere here, right? So less than 60 minutes means we are talking about all the area to the left of 0.60. So that's gonna be height is 1/80. I mean 1/180 times width is 60 minus 0 is 60. So this, which is 60 goes into 183 times, that's 1/3, or approximately 33.33%, right? 1/3 is 0.3333. Number 5, probability that someone spends more than 80 minutes. Okay, so 60 is here, let's say 80 is somewhere here. More than 80 would be everything to the right. So more than 80 is gonna be, so 80 here and 180 over there. So height is still the same, 1/180 times 80 to 180 is 100 minutes. 0, 0 cancel out. 2 goes into this, 10, 5. 2 goes into 18, 9. So it's gonna be 5/9, okay? So there's gonna be 5 divided by 9 is 0.5555, is approximately 0.5555, which is equal to 55.55%. Number 6, probability of X being between 60 and 90, okay? So let's draw another diagram for this. This is 0, this is 180, X between 60 and 90. So this is where 60, this is where 90. So we are talking about this strip in the middle. Okay. Is gonna be equal to 1/180 times 60 minus, 90 minus 60, which is 30, right? 1/180 times 30. 30 goes into 186 times. Is 1/6, which is roughly about 17%. Okay, approximately 0.1666, which is equal to 16.66%. Now let me add one more. What is the probability that someone waits exactly 90 minutes? So number 7, find the probability that someone waits exactly 90 minutes. What would that be?
0.
0. This is a single point, so the probability is 0. Now you have seen 2 solid examples, exactly same type, and it should be easy for you to be able to figure these things out. All right? You should be quite comfortable doing this. However, I understand that you are seeing this stuff for the first time and things are not so clear or maybe a bit cloudy. It's okay. Take your time. These concepts, it takes a little bit of time to sink in, but this one is rather easy. This should be okay. You watch the videos, so you'll need to use these videos that I'm recording, and you need to go over these couple of times before it makes sense or it starts to make sense. Give it a couple of weeks. So next couple of weeks are going to be challenging. Okay, once you get a hang of it, then it becomes kind of fun, honestly. So please be patient, bear with me, and stick in there. Just don't fall behind this time. If you fall behind with this stuff, then you'll not understand later on topics and you'll get frustrated. So I really want you to focus heavily on the videos and the homework these 2 weeks. All right. One last time, any question on this topic before I move on to the next topic, which is normal distribution and consequently standard normal distribution?
I don't have any questions. Thank you.
You're welcome. Anybody else?
For part 3,
Uh-huh.
you're factoring, I guess.
Mm-hmm.
How do you get the square root of 3?
Because 2700 is 900 times 3. Then you could break it down into using the properties of radicals. You could break it down to square root of 900 times square root of 3. Remember the rule, square root of a times b is equal to square root of a times square root of b, or in general, the nth root of a times b is equal to nth root of a times nth root of b. Remember that?
Yes.
That's the rule I have used.
See. Okay. Thank you.
This is from intermediate algebra. Maybe you have forgotten about it because you took the class a while ago or whatnot. So this is a rule. Remember that. You can do that. This one and this.
Mr. Hussain, do you always have to use that rule in that situation, or is there an easier, quicker way to do it?
You don't have to use it. I just did it because I want you guys to get a flavor of doing calculations by hand. You could just literally take your calculator and find the square root of it. It'll do the job.
Okay, thank you.
Mhm. All right, so next, normal distribution, something you have seen before. Okay, bell-shaped curve, normal distribution, Gaussian distribution, we have talked about. The formula for this normal distribution is actually this one, the one you are seeing on the screen. This is the formula for normal distribution. F of x is equal to 1 divided by sigma, which is the standard deviation, times square root of 2 pi times e to the power negative x minus mu whole square divided by 2 sigma square. That's the formula that defines these curves. Depending on what sigma is, what mu is, you will get different curves. Okay? Depending on what sigma and mu's are, you'll get different curves. And this x, by the way, in this case, this x, the random variable x, it takes its value from negative infinity to positive infinity. Even though we just show it up to a certain point here, it falls off extremely quickly beyond 3 standard deviations. Literally, it goes to 0, but it is not exactly 0 ever. So again, the same thing from negative infinity to positive infinity. Okay, that is what it is. And when we say bell-shaped curve, normal distribution, Gaussian distribution, all of these are the same. Now, look at these curves. Both of them are bell-shaped or normal distribution, but they have different means and different standard deviations. This one has less variation. Remember, standard deviation tells you or give you a sense of how close the data points are with respect to the center or the mean. In this case, for the blue one, the mean is what? 0. For the blue one, the mean is 0. And you can see most of the data points are centered around the mean. The peak is somewhere here. On the other hand, for the red one, the mean is 1. Most of the data points are centered around 1. However, this one has a higher standard deviation compared to this one, just by visual inspection. Okay, because This is wider. So red one is wider, whereas the blue one is more compact. Clear, everyone? Any question, anybody?
No.
All right, let's move on. Properties of normal distribution. This is something, some of it I already talked about it. The random variable x, for normal distribution, random variable x will take on any value from the number line. That means it goes from negative infinity to positive infinity. It goes from negative infinity to positive infinity. The distribution is bell-shaped and symmetric. So it's bell-shaped. That's what the bell, like maybe the church bell. Symmetric means if you look at the mean mu and draw a vertical line here, left side is a mirror image of the right side and vice versa. Right side is a mirror image of the left, or left is a mirror image of the right, which is what it means to be symmetric. But there are other forms of symmetries, but here we are going to just talk about very simple symmetry about the vertical line. All right. One symmetry I kind of want to touch on is perfect symmetry, which is a circle. Doesn't matter. Through the center, anywhere you draw a line, it's symmetric up through the center. Okay. So next, the mean mu is the population parameter that is the center of the data points. Okay. So mu is the center of the data points, or the middle, right? As you can see here. Variance sigma square, a positive number that defines the spread of the data points. So sigma square, or equivalently sigma, it tells you how spread out the data points are compared to the center or mean of the data set. And a distribution, a normal distribution, is uniquely determined by mu and sigma square. This is sigma square, not sigma 2, sigma square, because PowerPoint doesn't allow me to bring in LaTeX easily. So if you have a normal distribution n with a mu sigma square variance, if you know mu and if you know variance sigma square, that uniquely identifies a normal distribution. That uniquely identifies a normal distribution. Like two, if you give two different points, that uniquely identifies a straight line, right? If you give two different points, you cannot have two different straight lines through those points. There is only one line through those points, and that's a unique line. If you are given two other points like this and this, that's another unique straight line. So similarly, you can think of when you are given mu and you are given sigma square, you are uniquely identifying this normal distribution. Unique identification, by that I mean there is only one such normal distribution with this particular mu and particular sigma square. That's what I mean. Any question, anyone, about the properties of normal distribution? Okay. Cumulative density function. This is an important concept. So that basically tells you the probability from negative infinity to up to that point. So in this case, look at the point, this point, let's call it point A. So probability of x less than equal to A. That means everything to the left. That's the cumulative probability up to a certain point A, okay? And it itself is a function, by the way. Now, interestingly, if you draw the cumulative density function, okay, for normal distribution, it kind of looks like this. And it approaches 1. This is 1, okay? This is called elongated S curve, okay? Elongated S curve. Cumulative density function. Remember, it accumulates all the probabilities to the left. Okay, it accumulates all the probabilities to the left. One quick question for this one, 0. What is the probability of x is less than or equal to 0 in this function? Can anybody quickly look at it and tell me? You should be able to give me a number. What is the probability of x is less than or equal to 0 here?
Is it 5?
5?
Yeah, because there's 5 points to the, was it from 1?
No, probability cannot be more than 1 or less than 0, remember?
Oh,
Or
yeah.
between 0% and 100%. Anyone else? No questions? Anybody? No one knows? 2, please remember, probability cannot be a number bigger than 1 or less than 0. It has to be between 1 and 0. Or if you express it in terms of percentage, it has to be between 0% and 100%. Okay, George got it. 0.5 or 50%, right? So 0 goes to right, the middle, right? And this is a symmetric curve. So to the left is going to be half of the probability, to the right, half of the probability. So left is 50% and the right is 50%. So this is 0.5. And you could answer the same question for the right side. Probability of x greater than or equal to 0 is also 0.5. Okay, next. Standard normal distribution, which I have talked about before. Normal distribution that has a mean of 0 and standard deviation of 1 or variance of 1. If you have a normal distribution that has a mean of 0 and standard deviation of 1, it is called standard normal distribution. And please keep in mind, okay? Standard normal distribution has a mean of 0 and standard deviation of 1. Now, z-scores example. So this is where I will be spending a bit of time and give you some examples, okay? Let's talk about something here first. If you have a normal distribution, any normal distribution with a mean of, let's say, mu, or it could be x bar, sigma standard deviation, or s standard deviation of the sample. This is some arbitrary number, you don't know. You can go back and forth between this one and the standard normal distribution, which has a mean of 0 and standard deviation of 1. Okay, mean of 0 and standard deviation of 1. So this is the standard normal distribution, and this is the normal distribution. Is it clear? How do you go back between these two? Back and forth. Anybody remembers what do you use? Okay. Z is equal to x minus mu over sigma, or z is equal to x minus x bar divided by s. Z is equal to x minus mu over sigma, or z is equal to x minus x bar over s. For the case of sample, we use this. For the case of population, we'd be using that. And you can go back and forth. You can go from normal distribution to standard normal distribution, or from standard normal distribution to normal distribution using this formula. And this is something that we will be playing around with a lot. So I want you to get used to this. All right. So let's go ahead and work on the problem here. So the average income in a city is $35,000. All right. So the average income in a city is $35,000 and standard deviation of $10,000. Assume that the income in the city is normally distributed. So for simplicity, we are assuming that income distribution is pretty much normal. Now, here I ask you to find the z-score for someone who makes 38,500, z-score for someone who makes 30,500, and find the corresponding income for someone whose z-score is negative 1.35, and find the corresponding income for an individual that has a z-score of 0.75. So there are 4 problems here. They are all similar and all use the same formula. Z is equal to x minus x bar divided by the sample standard deviation. So I'm just going to take this window off. So remember, you have a bell-shaped curve that has a mean of 35K or 35,000 and standard deviation of 7,000. And then we have to get to standard normal distribution that has a bell shape, that is of course has a mean of 0 and standard deviation of 1. And between these two, we use x minus x bar divided by s to go back and forth. So someone makes 38,500. So let's say this is 38,500. Someone makes 38,500. We need to map this point to some z-score here, z. Look, when you're mapping any normal distribution to standard normal distribution, keep in mind that this middle point, the mean, maps to the 0. Mean maps to 0. A point to the right of mean in this graph will be a point to the right of 0 in this graph. So 38,500 is to the right of 35,000. So z for z-score for 38,500 would be to the right of 0. So this point. Now, how do I find that? We know z is equal to x minus x bar divided by s. My x is the pointed question that I'm translating or mapping is 38,500 minus x bar is 35,000. All of it divided by the standard deviation, which is 7,000. So that is going to be 3,500 on the top divided by 7,000. That is, by the way, just 1/2 or 0.5. So z-score is 0.5. Remember, if z-score positive means it's to the right of 0. Z-score negative means it's to the left of 0. Once again, z-score positive means is to the right of 0. Z-score negative means is to the left of 0. Now, the next one was for how much? 30,500. So if it is 30,500, what is it going to be? Z-score. So 30,500 is probably going to be somewhere here. 30,500. So it's going to be somewhere here, your z-score or z-value. So let's do the calculation. X minus x bar divided by s. So that's going to give you x is 30,500 minus 35,000 x bar, 7,000 So 30,500 minus 35,000, I think it's 4,500 divided by 7,000. These two zeros cancel out. 5 goes into this 9 times, 5 goes into this 14 times. So it's gonna be 9 over 14. And what do I get? Oh, I made a mistake. Nobody realized it. This is minus, right? 30,500 minus 35,000 negative. So this should be negative. It's gonna be 9 over 14 is 0.6428 negative. So negative 0.6428. Just to put it in negative 0.64, negative 0.64. So z-score for 30,500 is negative 0.64. So this is your A, where x is equal to 38,500. That's your B, where x is equal to 30,500. But C, they give you Z this time. Someone that has a Z-score of negative 1.35. What is the corresponding income? Now, this is slightly different, and let me draw another diagram for this so that you guys get a feel for it. In this one, we went from the normal distribution to standard normal distribution. But in the part C and D, we are going to go from standard normal distribution to standard normal distribution to normal distribution. So you're going to go from here. So you're given this Z-score 0, negative 1.35. So someone, standard deviation 1, someone falls to the left and that person's Z value is negative 1.35. What would it map to in this? What would it map to in the normal distribution that is under question here, which is, by the way, has a mean of 35,000 and standard deviation of 7,000. Okay, mean of 35,000 and standard deviation of 7,000. Okay, now again we're going to use the Z value, Z formula. Z is equal to X minus X bar divided by S. So we just do the calculation here. Let's do it on the right. Z is equal to X minus X bar divided by S. Now Z is given to be negative 1.35. So we are trying to find the corresponding point here, corresponding X value, the thing that's going to map right to X. So negative 1.35 is equal to X is the point in question that we are looking for, minus X bar is 35,000, all of it divided by 7,000. Now you multiply both sides of this equation by 7,000 so that you can cancel things. Okay, 7,000, right? So these cancel out. That gives you X minus 35,000. So 7,000 times negative 1.35, 7,000 times, that is negative 950, negative 9450. Now you add 35,000 to both sides. Then you're going to get X on the right. That's going to give you 25,550. 25,550. So this point is going to be 25,550. So that is how you go from standard normal distribution, standard normal distribution to just normal distribution. That's how you go from standard normal distribution to normal distribution. Any question about this problem?
No, it didn't seem a little hard, just quite a bit of steps, but so far so good.
You'll get used to this, trust me. So the other one is what is if z scores 75, I mean 0.75. So in the next one, z score is 0.75. Z is equal to 0.75. Z is equal to 0.75. Again, 0.75 is going to be somewhere here, right? 0.75, and you're going to get a corresponding point here. So this point will map to that point, which is x is equal to something. So we are going to do the same game. Z is equal to x minus x bar divided by s. Z is 0.75 is equal to x is what we are looking for. X bar is 35,000 divided by 7,000. So if you multiply both sides by 7,000, so 7,000 times 0.75 is 5250. So 5250 is going to be equal to this, and this cancel out. X minus 35,000. If you add 35,000 to both sides, right? It's going to be 40,250 on the left. On the right side, this is just x. So x is 40,250. That's what it is. $250. Any question, anybody, about this?
No, it's giving me flashbacks of algebra class though.
Okay, good to know. No questions? Anyone okay? Everyone okay? All right, I'm going to stop here. I think I gave you plenty of information for the day. What I'm going to do is assign you some homework tonight on these topics. You can go ahead and work on them over the weekend and also the next couple of days, and watch this video. Okay, go over this video multiple times. You'll need to watch it multiple times to get a sense of what I'm talking about. So initially, it takes a little time to consume this information, as I am, as you guys are learning for the first time, probably. So please go ahead and look at the video and look at the homework, try the homework, and if you have any questions, please send me email. And when you are sending me emails about a question, please send the email from the question itself. Don't send me an email from your Gmail saying that I need help with problem number 5. You just send me an email. There is an email link to the right. So you'll see an email link, something like that. Email link from the question. As you are working on the problem, there is an email link. Click on this and you upload an image or just write some comment and say that I'm stuck. If you do email me from here, it actually sends me the problem that you are working on, and it shows me what answer you have there. So that's why I'm asking you to do this. That way I know exactly what problem you are working on. And then if you write a little description or take an image of the problem that you're working on, that'll give me a great sense of what your problem is. And right away I could help you, as opposed to saying, can you please help me with problem number 5 in homework so-and-so. So please do so. And this is halfway through the semester. You should know it by now. All right. All right, unless you have any other questions, that should be all for today. Thank you so very much. Have a wonderful evening and rest of the week and weekend. Enjoy your weekend. Stay safe, stay healthy. All right, thank you.
Thank you, Professor.
Thank
Thank you,
you.
Professor.